Addendum video. So in my otherwise best video tape from Wednesday, January 12th, I did miss one detail. So I'm going to go back and fill that in. So let's say you got this jet, it's moving. We're looking at the Doppler effect. It was catching up to the waves that was sending out. So the person that the jet is approaching perceives a high frequency. Here's the map on that. The person the jet's going away from, here's a low frequency. But what if this jet was actually traveling faster than the very sound waves it was sending out? Let's say it was traveling faster than the speed of sound, faster than these rip waves it's sending out. What would that look like? So here's this jet traveling along this path. When it was back here, let's say it sent out a sound wave, something about, here's how far that wave crest gets. When it was back here, it sent out a sound wave. It looks like this. And when it was back here, it sent out a sound wave that's now propagated, let's say about this far, something like that. All right, so yeah, this jet is definitely beating the sound waves it's sending out, it's traveling faster than those. Now I drew 3 circles here, but I could have drawn, say, 100 circles. And what you would see after a while, draw so many circles, is that they you can sort of like line up their circumferences like this and create. Ooh, it looks like a wedge shape, or maybe kind of like a triangle. Now consider this is actually in 3 dimensions. These are actually spheres, not circles. These are spheres, right? Because waves are traveling in 3 dimensions. That would make this a wedge shape, maybe like a cone, right? Like a cone shape. The fact that this plane is traveling faster than sound, what's that called? That's called supersonic. If you break down the word super, greater than, sonic is sound. Okay, so greater than the speed of sound, faster than the speed of sound, supersonic. You can quantify this too. So how many times faster than the speed of sound? If you've ever heard a term like Mach 2, for example, a Mach number tells you how fast you're going compared to the speed of sound, which of course speed of sound is different in different media. Through air, it's approximately 340 centimeters per second, 1 Earth atmosphere or room temperature. Okay. So Mach 2 refers to twice the speed of sound. If you hear Mach 3, that'd be 3 times the speed of sound. What about this jet? How I've got going right here? Well, let's see. Looks like when it was back here, it sent out this particular sound wave, and the jet's gone approximately twice as far. So this particular jet actually does look like the fact this is a 2-to-1 ratio, 2 to 1. The jet's going twice as fast as the sound waves it's sending out. This jet actually would be Mach 2. Yeah. How about back here? The jet's gone, yep, it's about a 2-to-1 ratio. Pretty close. All right, so and you can imagine that the faster the jet's going, maybe like the narrower this cone's going to be. Hey, what if you were down on the ground? Here's the ground down here. Let's put a person right here. Now, this person has watched the jet fly overhead. The jet's already like past this person overhead. Has this person heard the jet yet? No, because notice that none of the sound waves have actually reached this person yet. Now they will, and when they do, they're going to reach him all at once. And this guy's going to experience a sonic boom. You hear a sonic boom whenever anything's traveling at supersonic speed because you get this this type of effect. I want you guys to see the see a demo of this. So let me present my screen. What does this look like? So here we got, you're seeing the silk frame. Here's a jet, supersonic. Can you see that flat wedge? The fact that it's a cone that's pretty flat means that jet's going just barely faster than the speed of sound. Let's zoom through this. You see these condensation clouds that appear to be following the jet. Actually, they're being created instantaneously. So, ooh, yeah, you see like nice cone shape right there, right? So those condensation clouds are instantaneously being created and dissipating.
All of these factors are.
Oh, and there's a nice animation. The faster the jet's going, the narrower that wedge.
We do get a glimpse of something special. At Kennedy Space Center on February 11, 2010, an Atlas rocket launched into ideal conditions for showing off shockwave. And this is the result. Oh.